Chapter 1, Matter in our surrounding, Class 9th. What is matter? Matter is anything which occupies space and has mass. Classification of matter. Early Indian philosopher classified in the form of 5 basic elements as air, earth, fire, sky and water, called Panch Tattva. On the basis of the physical state, matter is classified as solid, liquid and gases. On the basis of chemical composition, matter is classified as pure substances and mixture. Pure substances may be elements or compounds. Mixture may be homogeneous mixture or heterogeneous mixtures. Second, physical nature of matter. Number 1, matter is made up of particles. Number 2, the particles of matter are very tiny. Third, the particles of matter have space between them. Fourth, the particles of matter are continuously moving. And the last, the particles of matter attract each other. There is one activity on the basis of that is matter is made up of particles. Take some water in a beaker and note its level. Dissolve some salts or sugar in it with the help of glass rod. The salt dissolves in the water, but the level of water does not change. This is because due to the particles of water get into the space between the particles of water. This shows that matter is made up of particles. Second activity, the particles of matter are very tiny. Dissolve 2-3 crystals of potassium permanganate in 100 ml of water in a beaker. Take 10 ml of this solution and dissolve in 100 ml of water. Take 10 ml of this solution and dissolve in 100 ml of water. Repeat this process 5 to 6 times. This shows that a few crystals of potassium permanganate can color a large volume water because there are millions of tiny particles in each crystal. The particles of matter have space between them. Take some water in a beaker and note its level. Dissolve some salt or sugar in it with the help of glass rod. The salt dissolves in the water, but the level of water does not change. This is because the particles of salt get into the space between the particles of water. States of matter. Matter exists in 3 different states. They are solid, liquid and gas. Number 1, properties of solids. First, solids have definite shapes and fixed volume as shown in the figure. The space between the particle is minimum. The force of attraction between the particle is maximum. The movement of the particle is minimum. They are least compressible. Their rate of diffusion is least. Properties of liquids. Number 1, liquids have no definite shape but have fixed volume. Liquids take the shape of the container. Second, the space between the particles is intermediate. Third, the force of attraction between the particles is intermediate. Fourth, the movement of the particles is intermediate. Fifth, they are less compressible. Last, their rate of diffusion is more than solids. Properties of gases. Gases have no definite shape or fixed volume. Gases occupy the whole space of the container. Second, the space between the particle is maximum. Third, the force of attraction between the particle is minimum. Fourth, the moment of the particle is maximum. Fifth, they are most compressible. Last one, their rate of diffusion is more than solid and liquid as shown in the figure. See in the figure, gas, liquid and solid. The movement of particle is more as compared to liquid and solid. Change of state. When a solid is heated, it changes into liquid. When a liquid is heated, it changes into gases. When a gas is cooled, it changes to liquid. When a liquid is cooled, it changes into solid. For example, if ice is heated, it changes into water. If water is heated, it changes into steam. If steam is cooled, it changes into water. If water is cooled, it changes into ice. See, ice. Ice is melting. The particles are close together and cannot move about. Water. The particles move faster and further apart. In the third, boiling water, the particles are far apart and move very quickly and randomly. And again, after boiling the water becomes steam. Melting. What is melting? That is fusion. When a solid is heated, the particles begins to vibrate with greater speed and begins to move more freely. Then at a particular temperature, the solid melts and changes into liquid. The process of melting is also known as fusion. The temperature at which a solid melts is called a melting point, and the melting point of ice is 0 degrees Celsius, or in Kelvin 273 Kelvin. Latent heat of fusion. What is latent heat of fusion? The amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is called the latent heat of fusion. You can see in the picture. Boiling. When a liquid is heated, its particles begin to move even faster. Then at a particular temperature, the liquid begins to boil and changes into gas, that is vapor. Boiling is a bulk phenomena. When a liquid boils, the bulk of the liquid changes into vapor. The temperature at which a liquid starts boiling is called its boiling point, and the boiling point of water is 100 degrees Celsius, or 373 Kelvin, that is 273 plus 100. What is latent heat of vaporization? The amount of heat energy required to change 1 kg of liquid into gas at atmospheric pressure at its boiling point is called the latent heat of vaporization. See the effects of temperature on molecular motion. In solid, when it is in cold and when it is in hot, and in liquid, when it is in cold and when it is in hot, as you can see in the picture. Sublimation. The change of state directly from solid to gas or from gas to solid is called sublimation. Example, if solid camphor or ammonium chloride is heated, it changes into vapor. If the vapors are cooled, it changes into solid, as you can see in the diagram. Effect of pressure on gases. When pressure is applied on gas, the particles come closer and the gas changes into liquid. We can liquefy gases by applying pressure and reducing the temperature. Compressed solid carbon dioxide is called dry ice. If the pressure is reduced, it changes directly to gas without coming into liquid state. So, solid carbon dioxide is known as dry ice, as you can see in the figure. Interconversion of the three states of matter. The states of matter are interconvertible. The state of matter can be changed by changing the temperature or pressure. As you can see in the chart, solid can converted into liquid and solid can convert it into gaseous. Gas is converted into liquid and liquid is converted to gas. The process the solid is converted to liquid is called fusion, and liquid to solid is solidification. Solid to gas is sublimation and gas to solid is sublimation, and the gas to liquid is vaporization and liquid to gas is condensation. Evaporation. The change of liquid into vapor at any temperature below its boiling point is called evaporation. Evaporation is a surface phenomena. Particles from the surface gain enough energy to overcome the forces of attraction and changes to vapor state. The factors which affecting the evaporations are increase in the surface area increases the rate of evaporation, increase in temperature increases the rate of evaporation, increase in humidity decreases the rate of evaporation, and increase in wind speed increases the rate of evaporation. You can see the high energy evaporating and in the medium pulled back into water, and lower energy remains as liquid. Evaporation causes cooling. When a liquid evaporates, the particles of the liquid absorbs heat from the surroundings and evaporates. So, the surroundings becomes cold. Example, people sprinkle water on the roof or open ground because during evaporation water absorbs heat, makes the hot surface cool. During summer, we sweat more because during evaporation the sweat absorbs heat from our body and making the body cool. Wearing cotton clothes in summer keep us cool because cotton absorbs sweat, and when the sweat absorbs, it absorbs heat from our body and making the body cool, as you can see in the figure. You can see how evaporative cooling works. Warm air, water absorbs, it comes cooler air, that is 18 to 25 degrees Celsius. See in the diagram about the desert cooler. In our houses, it is mostly available in summer season. How our desert cooler works, you can see in the diagram.